Well, good morning, good afternoon, and good evening. My name is Dylan, and we're just going to wait about a minute or so for everybody just to jump online. We've got a nice proportion of everybody here, but we'll just give the stragglers 60 seconds or so to connect, and then we'll get going with our webinar. Okay, well, welcome again, and thank you for all for joining our webinar today. My name is Dylan Kassane. I'm on the marketing team here at Witekio, and along with our good friends from Avnet Embedded, Qt, and Microsoft, we're very happy to welcome you to IoT Product Design, Make or Buy, How to Make the Right Move. Now, we've got a very full agenda today as we dive deep into that discussion that's something of a classic in the product circle. Do you stay in-house? Do you outsource? Do you buy off the shelf? Do you build something from scratch? We're going to cover all of that in the hour ahead. Now, before we get going, just a couple of definitions to make sure we're all on the same page. For the webinar today, we're going to be discussing all of the different layers of an IoT project, hardware, the embedded software, and the cloud as well. When we talk about make and buy, we're talking about either buying one or more of those layers off the shelf, that's the buy side, or developing one or more of those layers in-house, that's the make. Now, it's not all black and white. If you're hoping for a definitive definitely buy or always make, you're probably going to be disappointed. Instead, we're going to be focused on the advantages and disadvantages of making or buying some or all of any of these layers. We're going to take a close look at criteria like time to market, your company culture, long-term upgradability, IP ownership, balancing risk, and the total cost of ownership. In short, we'll be looking for the right way forward. So let me introduce you to the four experts who are going to be showing us the way today. First up, let me welcome Anatoly Lukarinen, Technology Advisory Manager at Avnet Embedded. Anatoly, can you tell us in a couple of words who you are and what Avnet Embedded does?
Yeah, thank you, Dylan. My name is Anatoly. I'm Technology Advisory Manager for Avnet Embedded here in Americas. Really, my role is to help customers to choose the right type of embedded compute hardware for the OEM products. I've been in embedded compute business for roughly 16 years, and yeah, that's really shortly about me.
Fantastic. So next up is Harrison Donahue. Harrison is a strategic account manager at Qt. Harrison, tell us about yourself and what you do at Qt.
Sure. Thanks, Dylan, for the introduction. So for those of our attendees who are maybe less familiar with Qt, I'll just briefly tell you guys about who we are and what we do. So Qt is a software company. We offer a cross-platform development framework, that's libraries and APIs to make use of that source code, as well as a very feature-rich set of tooling and IDE that we put out, as well as a design suite to import your designs directly for your product. We've been building on that now for over 20 years. My role specifically with Qt, prior to joining, I was an embedded developer working in the IoT connected home and security products. So a lot of the things we'll talk about today are near and dear to me and things that I've experienced and had to personally weigh. Today with Qt, I manage a handful of our strategic IoT customers within the Americas, as well as drive our business development. I'm quite involved with our Qt for MCU offering, which is a newer component of the framework.
It's good to have you, Harrison. From Microsoft and Azure, we welcome Scott Gadinger, Strategic Account Lead for IoT and Cloud. Scott, introduce yourself and tell us what is this Microsoft organization all about?
Hey, Dylan. Yeah, thanks for that. And thanks all for joining. I really appreciate you taking the time today to listen to our presentation here. My role at Microsoft, actually, I'm in an IoT partner ecosystem team. That means I get to work with great companies like Witekio and Avnet and Qt on different embedded devices. 18-year veteran at Microsoft, so I've seen quite a bit at Microsoft over those couple of decades. I'm actually about 25 years in embedded and several different roles at Microsoft. Excited because Microsoft is really re-engaging in the embedded space. And I think you're going to see a lot of offerings, coming out in the near future. And so, yeah, we're definitely excited about Witekio and Avnet QT and discussions here, as well as I have a great job at Microsoft because what I get to do is work with not only these great partners, but people like you to really create who are innovating new devices and new edge technologies. And it's an exciting space. So a lot of fun. So thanks for the invitation there, Dylan.
It's good to have you, Scott. And finally, happy to welcome our own Pierre Gall, Technical Director here at Witekio. Pierre, tell us a little bit about yourself and about Witekio.
Yeah, sure. Thanks. Hi, everybody. So I'm Pierre Gall. I'm Technical Director, working at Witekio for now 15 years, and play a lot of different roles at Witekio, but always on the technical side. Today, make our customers succeed in their project, in their development. We are able to. The Witekio value proposition is to propose to help and to support our customer from the very low level development of the solution till the cloud development. So we are really happy to have this webinar today with all our strong partners, and that's it.
Perfect. Thanks, Pierre. And of course, it's great to have you here, our audience as well. If you've got questions during the webinar, you can add them using the button at the bottom of your window. And we're going to get to as many of those as we can in some Q&A time that we've allowed for right at the end. Do add them as we go, and we'll be sure to get to as many of those as we can. So, why are we all here? In a nutshell, it's about making the right choice when it comes to a new IoT project. Are we going to optimize something that exists, renew hardware and software that's already out there, or build something from scratch? How are we going to transform the vision for an IoT project into action? In other words, are we going to make or are we going to buy? Let's kick things off in this discussion with Anatoly, who's going to look at the hardware side. Anatoly, over to you.
Thank you, Dylan. All right, so I'm gonna just go try to go pretty quickly through different things to consider when you are thinking about the hardware and thinking about making or buying the hardware for your solution, for your product as a customer. So obviously there's a couple of obvious benefits, and then there's obviously some potential drawbacks of both approaches, making or buying. One of the obvious benefit is reduced complexity. If you buy your hardware from somebody who's already designed, especially maybe the hard part, the core part of the compute, let's say, the DRAM, everything around DRAMs, flashes, high-speed signals, also potentially implemented the BIOS on the x86 platforms and all that stuff that you can offload your design team to somebody else. That is pretty complex, and it can take a lot of time and a lot of money if you start developing that from the scratch. That also is related very closely to the quality portion of it. If you buy something that's already been designed and tested and verified, especially that core technologies, that core hardware, you can probably be pretty reassured that it's a proven design, it's tested design, especially if you choose the supplier for your hardware that you're buying carefully, and make sure that it's actually designed for 24/7 operations, for industrial applications, for your specific use case. You can be pretty sure that it's gonna have a good quality, and you don't have to worry about if you design something from scratch, is there gonna be some issues with it or not. So in overall, you can basically optimize your total cost of ownership of that hardware, and make sure that you reduce the complexity of your project, and make sure that you have a good quality embedded compute inside of that. The other obvious benefit is the faster time to market for when you're buying a hardware, meaning that you don't have to spend time reinventing the wheel for yourself, and your developers can focus on developing something that actually brings additional value to a product. It can enable you to faster development cycles. Again, it can reduce the development risk for you as well. And that's really one of the big benefits for if you're buying a embedded compute hardware instead of designing everything from scratch. And that again is very tightly connected to stability of the hardware as well. So first of all, you can reduce time to market, but then buying hardware also offloads your team and especially the product management team and operations team, purchasing team, with the stability of the product, especially stability of the compute hardware that you're using. So basically, you're offloading your team to manage the life cycle and BOM control and low level software management of your hardware to somebody who's basically have it covered for you. Again, very important to understand that you need to be very careful when you're choosing a supplier for such a project, because there's a lot of compute out there and compute hardware out there in the market that are definitely not designed for longevity or BOM control or anything like that. That's more designed for consumer type of applications. So if you're not in that consumer type of space and more in industrial space, OEM space, more professional type of appliance type of space, you definitely need to do your homework and choose the right supplier for yourself. So all of these benefits are there, but they're not given. So just keep that in mind as well. Another couple of things is the future-proofness and scalability that also goes pretty well hand to hand. If you're buying hardware, if you're buying certain type of hardware, and you can really build yourself a platform. You can obviously also design yourself a platform, but really the benefit of buying hardware and designing your product based on the hardware that you buy and based on the platform idea is that you can use the future developments of the hardware also without doing a redesign yourself. So you can really build a forward compatible platform for yourself. You can upgrade your platform without redesign. You can extend the life cycle of your platform. All of these things becomes available if you designed your product based on the hard platform type of hardware that you can buy from the market. And I'm going to talk a little bit more about that in the next slide. And also the scalability. It's pretty much the same thing here. That it allows you to build a product that is highly scalable from the performance, features, and cost perspective. You can even build a multi-architectural platforms. You really have a flexibility without doing a full complex redesign in-house. So there's all these great options available in the market if you know where to look them for that can help you to build your product much faster, reduce your workload of your engineering team, focus your engineering team and work where you can actually bring more value and buy the core hardware from somebody who's focused to servicing your type of applications and your type of market. So I already kind of started to touch base this topic of using a system on modules, especially standard system on modules as a buy hardware. So what we see in the market today, actually pretty heavily, is that there's two types of different applications and different customers are moving very heavily towards using a standard SOMs, and for a very good reason. There are customers who have previously designed everything in-house from scratch, quote unquote chip down designs. That's the ones on the left side of the screen. And then at the same time, we have actually a lot of customers and a lot of people who have used very standardized compute platforms like a motherboards, like off the shelf single board computer type of products. They're also moving away from that approach to standard SOMs. And there's two different motivations there, obviously on the both sides. So for the chip down perspective, if you are the customer who have built everything from the chip down, obviously the benefits are for you that you can offload your engineering team, you can speed up your time to market, and you can have that core compute design, core compute platform provided for you without you having to worry about it. And then you can still design, you can still keep control. That's typically what a lot of customers are worried about, that they still want to keep control of their products and their product design. You can still keep control of the form factor of the complete design for the IOs, for different connectivity, and so on and so forth. So that's really the guys who are coming from the chip down design, that's the benefits they will see. And then there's another guys who are coming from the standard, very standard motherboard, standard single board computer space. They are looking to regain that control. So they felt that they went way overboard of buying instead of building something in-house. They went too far in that buy space, and they want to take a step back, because now they realize that, hey, we actually can bring more value to our product as a customer if we can control the design of the carrier board, control the IOs, control these important things for our product, and bring actually more value to our product. But we still want to buy the wheel that is already invented, and that's the SOM, because that's design. It's always the same. If you buy a CPU power, computing power, everything that's around that's always going to be the same, regardless what's your end product's going to look like. So they want to take a step back from buying a complete board that is fully standardized for basically everybody. Now they want to take a step back and design the carrier board themselves, take some of that control back, but still have most benefits of buying a hardware. And really the important thing before I wrap it up here is when you're choosing a SOM as a customer, if that's going to be a strategy, that you're going to want to buy a SOM system on module, and then you want to design the carrier board for your specific product. It's a great strategy. Just keep in mind there's a lot of SOMs out there, so all SOMs are not equal. So just keep in mind that industry standard based SOMs are much more secure, much more safe solution for you from multiple different perspectives. So first of all, there's a lot of vendors who comply with the standards, meaning that you can have a multi-vendor strategy for yourself, and also you can really take advantage of that scalability and upgradability if you're using a standard SOMs instead of if you choose some proprietary SOM design that who knows what's going to happen to that, and only one company manages that. Then it's so I really want to kind of wrap it up with that message here today. All right, that's about for me. So I'm gonna hand it over for Harrison. Take it away.
Perfect. Thanks, Anatoly. And we're going to jump from the hardware layer now into the software and the cloud layer. We've got a few different things that we're going to run through. I mentioned them at the start there, but we are going to kick off with Harrison, who's going to talk us through time to market and culture. Over to you, Harrison.
Thank you very much, Dylan. Yeah, I think the first one I'm going to cover here for you guys is time to market, right? And all of the topics that we're going to talk about today are so important, but time to market, I think, is one, as I'm talking to the developer community, both existing Qt customers and prospective. This one has a lot of pain around it today, right? With all of the issues with the chip shortage, teams being dispersed and working remotely and trying to avoid vendor lock-in as all this is going on. It's so important that we look at how can we tackle some of these challenges that have slowed us down in the past, but maybe to a point that's less significant than it is today. So with that, I will get into it. So time to market, obviously this is the clock that we're all up against, right? That has a significant impact on the success of our product. A missed market window in some scenarios can be the difference between success or failure. Now, the faster you get to market, the sooner you can begin to sell your product, recouping your investment, the longer you can lead the competition, and the sooner you can learn where you need to improve. Time to market is also your company's ability to react to trends or threats, right? So whether you're already late in addressing a competitor's offering, or maybe you're all reacting to a new and very disruptive entrant, it's important to get your product out quickly. So how can you ship your offering the fastest? Should you make or should you buy? And it doesn't have to be black and white, but depending on what you choose to take off the shelf, first reinvent is certainly going to impact your time to launch. So there's a few things you need to consider. One is your present resources, right? What are the skill sets you have in-house among all of the different parts of the organization that are going to be involved in going to market? And what is their present bandwidth? How big is your team? How is it growing? And what do they currently have on their plate? You also need to consider what is the MVP, or the minimum viable product with a feature set that you can release to really deliver that baseline value. And of course, if connected, then build upon. And lastly, remembering the 80-20 rule. 80% of your value is typically in 20% of the features. And so that's usually your differentiating special sauce, the stuff that really matters. Most of your product is just that foundational architecture required to deliver those few features. And those are wheels often not worth reinventing. So when it comes down to make or buy, we'll start with buy. An existing product obviously means less time spent reinventing, right? But when shipping an IoT product, there is this growing expectation that these devices are going to last longer, and they're going to continually be improved, right? Customers are not looking for, I'm going to buy this generation and then throw it away when the next generation comes out. You need to be sure that what you're taking off the shelf is not only mature and robust, but it will continue to be maintained in accordance with your product's life cycle. You also can't forget the integration of that off-the-shelf component with the rest of your application. That's the glue that brings all these pieces together. That could be a tremendous lift, depending on what you're buying and how many loose threads kind of need to be connected. So with Qt, for example, having a framework that offers tooling for developers and designers allows you to take some of those cross-functional workflows, like the UI UX design handoff is one that we often talk about. It can be significantly reduced in iterations, as well as taking what's really traditionally a serial process and parallelizing some of that effort between the designer and the developer. We also recently acquired Frog Logic and their QA tools, and that offering eliminates the need for manual GUI testing, which for those of you that have done it know that it can be quite extensive. So you can do scripted automation or behavior-driven development, and that allows you to ensure complete coverage is run at every step along the development process. Regarding maturity and availability, I think, as I said in the beginning, our product's been built on for over 20 years now. And with each major release, we put out LTS versions along with that are guaranteed to be supported for up to 3 years. And of course, there's always consideration to backwards compatibility and portability should you need to upgrade in the future. So let's look at the alternative to buy, which is the homegrown approach, or make. It's important to keep in mind that the IoT development life cycles can be long. Users are expecting products to last longer than ever, and with connectivity, they want them to evolve with new features and support for the growing ecosystem as time goes on. And this is why thinking about agile approaches and establishing that MVP is so important. It allows you to really manage your resources efficiently and put out the most impactful product as early as possible. Once that MVP is out, however, you're not moving to the next product. Like I said, you need to continue to maintain, fix bugs, and as you start to roll out other products, roll those upgrades into the existing product where it makes sense. With each product that's homegrown, it is ideal to build on a platform that can accelerate the time to market for the next iterations. Now, that might start to sound a little bit like you're buying, right? You're building something up that you can reuse later. But there are key impacts to doing that on your own that have an effect on your company culture. And I'll cover that in a minute on the next slide. For takeaways on time to market, buy is clearly faster, as you're not spending time reinventing any of the wheels, but you need to consider the maturity and availability of these components that may be critical to your product's foundation. Make, on the other hand, while the road is longer, it offers full control of that scope of your MVP. That's what's included, what isn't, and what will be added down the road. So onto company culture. Company culture is something that often steers the make or buy decision, but the inverse is also true. So if you're a new company or you're starting to shift from one path to the other, that can have a very significant impact on your company culture over time. Now, typically, company culture is created by the top-down management and company history around homegrown solutions versus purchased. But again, these can change as you guys move forward. Now, I've seen companies that have put so much value in reinventing the wheel, they home grow absolutely everything, and almost to a fault in markets that are particularly sensitive to that time to market or that cost of goods. Now, the make or buy scenario in this regard, we'll split it into two culture scenarios. Now, Qt doesn't exactly cater to one culture exclusively, but we'll look at the buy or the Playmobil culture first. So if you're familiar with Playmobil toys, you're working with a pre-assembled thing, right? A ready-made rocket ship or castle. You can pull these things out of the box and they're ready to use, but there are limitations with them. You have little to no control over the design of that rocket. And similarly, these limitations apply to all the components you're taking off the shelf for both hardware and software. This is what I call kind of the black box dilemma. You've got a module that does what you need it to, like go to the moon, for example, but you have no knowledge around how it was designed nor the ability to really modify it. And this is going to force you to make some compromises. Now, in the context of Qt, much of our tooling is focused on UI development, which allows you to take a low-code approach. Now, Qt Design Studio, for example, it allows you to import your design assets for your UI application and then generates the equivalent QML code automatically. The framework, while we're a market leader in UI development, also covers connectivity and OS management like file I/O, threading libraries, and APIs to the type level with alternative classes to C++, STL. Now, this is where we shoot the middle, though, because while all that source code is directly deployable, it's open. We do have a dual license scheme, and even if you are a commercial user, you have access to that source code. So it's easily modified to your needs, and of course, how you use the APIs is going to be specific to your application. Now, the alternative to the Playmobil culture would, of course, be the Lego culture. If you have a highly technical, home-grow culture, you're likely to be dumping a bag of bricks on the ground and constructing every engine and nose cone from scratch to your unique style and color. You'll end up compromising on very few elements of your design, that's likely. And this culture requires and cultivates a very strong technical knowledge. You need to have an understanding of how everything's built up internally, and in order to leverage those resources efficiently and effectively, you're going to have tailored processes in place to really support them, or be ready to subcontract certain components out if the time calls for it. Now, companies following the Lego culture tend to bring in and grow great talent over time, so it's also a great way to hire. Couple takeaways on this one. If you're following a Playmobil culture and buying everything, you can expect that you're going to need to make some compromises due to limited control over the design. If you're going the Lego route and making as much as possible, of course, within reason, it can start to initiate company transformation by upping your internal skill sets, developing new synergies, and making sure that your teams fully understand how everything works together, rather than kind of a select group of people who understand why the pieces were originally bought and how they go together. And with that, I'll hand it back to Dylan.
That's perfect. Thanks, Harrison. I'm going to hand the mic over to Pierre now. He's going to take us through our next couple of slides, starting with upgradability and platforming. Pierre, it's all yours.
Sure, thanks. So yeah, we will talk a little bit about upgradability and platforming. So that's probably something that I need to define before starting talking about that, because we are used to manage this kind of stuff in the projects that we are developing for our customers, but let's define it. What we are talking about platforming. Platforming is the ability to build a platform with the idea of reuse a small part or a large part of this development for building another project in the same range of product, for example. You can talk about platforming for hardware, for low-level development, and even for high-level application or cloud stuff. So platforming is the fact that you will reuse a part of your development to optimize the next one. What we are talking about upgradability is the fact that you are able to upgrade your system when he's in production. This is something that can be done quite easily in the cloud, and Microsoft can easily speak about how I can manage continuous deployment for my website. But this is also something that you have to manage on your embedded system. And it could be more complex. It will lead to security issue and a set of complexities that have to be managed. But it's a key topic in the development of a project to be able to follow the different evolution, to fix an issue, to fix a security breach. Now we are aligned on this definition. Let's focus on the topic. So it's important to understand when you are developing a project, what is the future, the ambitions of this development, because it will change. It will need to be adapted, the development strategy to fit this future. So it's clearly not the same if you just develop one single product, or if you are developing a full range of product with some derivative product. I just give you an example of one customer who are doing a coffee machine, industrial coffee machine. And we start development with them, I don't know, 5-6 years ago. And we think about a platform for this coffee machine. Just not about this one, but thinking that it will be easy to develop the next one. Today, we are at 12 different machines developed, and we have clearly optimized the development of any new machine they are doing. So it's really important in the strategy, even if it costs more at the beginning, it's really important to anticipate the future of your project. So why? Just because it will reduce the development cost, but you also have to think about the maintenance cost. When you are doing hardware and software, you need to anticipate the cost of this maintenance. Let's focus a little bit on upgradability. You are probably thinking about new project if you are in this webinar, new development, new solution, and probably some of them are doing new stuff, innovation solution, something that have not been done before. And that's why you need to anticipate the upgradability of your system. You need to say, okay, I will go fast. I will deliver something quickly to my customer, but I will need to be able to update it on the field for every customer easily, to be able to anticipate the fact that you discover a new usage or you discover something that is not fitting exactly your customers. Now let's focus on now buy and make regarding this quite technical topic. So if we start by the buy approach, for sure you can easily understand that you will have a high constraint environment. So you will be dependent to the supplier roadmap, for example. So you will not be able to develop whatever you want, the feature you want. So you have to anticipate that. This is a limitation when you are in a pure buy approach. And if your core value, if the core of your product is based on a product that you buy, be careful, because you will not be able to make it change easily. One also quick reminder, if you are buying a solution, your competitor can buy the same one. So clearly, you have to be careful of what you are buying. This is a really, really good way to enhance your time to market, but you just have to concentrate on why and what you are buying. Now let's focus on the make. On the make, for sure, you can have all the freedom of designing your solution with a platform, optimizing everything, building a relevant range of product based on that. You will have the higher upgradability, but there is one major issue for that kind of project is the complexity. If you try to anticipate in a range of product, you want to build an architecture to anticipate the future development. You need to manage all the layers or the stack of your development, low level, embedded application, cloud. You will need some skilled team. So you have to think about that and anticipate it. You can build your team internally and have the appropriate training for your team. You can also rely on an external company. And this is the value proposition of Witekio. And let's finish with the innovative project. If you are doing something where you know that you will need some evolution, you will have to use a make approach for doing it. Let's now move to the second topic. Let's a quick takeaway on this topic. So yeah, buy, review the roadmap of your supplier, be careful of your dependency, and be careful with your competitors that can have access to the same product. For the make, as I said, really easy to build whatever you want, but it's quite complex to build because of it could be already, technically speaking, complex. Let's move to the second topic for today. For me, we will talk about ownership. So ownership is a topic that is applied to all the level of your connected solution. You can buy an hardware, you can have software, we can talk about some patents, and we can also talk about the data. Data is an important topic for the ownership because if you are not able to, if you're not sure that all the data you are managing is not yours, or if the supplier you have selected can reuse your data for his own usage, you have to be careful, or where is your value? So ownership have to be really managed properly, managed correctly, and more particularly for your value proposition, for the core of your system, because this is what will make the difference from your competitors. So as you can understand, ownership and risk are both items that are strongly linked, and Scott will talk a little bit more about the risk in the IoT project. So let's focus a few seconds on buy. You understand the risk to be bound with a specific provider. What does that mean? That does not mean you don't have to buy a product. It could really make sense for a lot of different parts of your project, or for a short time to market. But that needs you have to anticipate some stuff. And one important topic to anticipate is what we call reversibility. The fact that you have a plan if you have to separate you from your supplier. And it's really important, for example, in your data. If you put all your data in a SaaS solution, no issue. It's quite time to market. You're able to have a solution on the market very, very fast. But be careful. How can you grab this data to extract it and to put it in the next version, in the future solution that you will develop? That have to be anticipated. Just before, I'm talking about technical skills, project management, developments, and so on. When you are buying a solution, you will have to manage contract stuff. So it's important to anticipate all the legal part of this solution. And to finish, and not the least, the value of your solution could be shared if you share the ownership of your data or whatever you want, the software. So you have to be careful with that to control your data and control where your value are. Let's focus a few seconds on the make approach. You have a full control. You have probably a full ownership. It will for sure lead to more resilience, but you have to be careful with these skills, and you have to maybe rely on internal or maybe on external skills. And to finish, last information I can share. Sometimes when you are creating a new product, during your development, you can create some assets that could be reused internally. But we also see some company who are developing a new business based on the development they have done for a specific product development. So you can have some positive effect of developing a full tailor-made solution. Key takeaway: buy. Don't forget about the backup plan for the make approach. It will for sure lead to more resilience, generate value, and that's it for me. Dylan.
Thanks, Pierre. We're going to hand straight over to Scott here. Scott, take it away.
Hey, thanks a lot. Appreciate that, Dylan. Next section is risk management. This one, oftentimes, sometimes we even forget about this until we're actually almost done with it. But it's a great topic to really add to this discussion, because definitely something we want to take under consideration and early in the project. And you can see there's a lot of different types of risks that you need to really think about, whether it's, of course, financial, technical. Those are a couple that we typically think about. But of course, cyber, security, we're looking at that more and more, and even safety. So a lot of different types of risks that you want to think through. And in terms of managing those, if you're looking at the make versus buy, really in terms of how that risk translate, it really changes the type and nature of that risk. If we jump down and just focus on the buy for a little bit, first off, buying that product, sometimes it doesn't fulfill all our expected what's on the spec sheet. Typically, we can manage through that by maybe trying the first version, second version, maybe third version. Maybe the supplier didn't test something completely or fully complete something, and maybe it's easy to fix and meet those expectations. But sometimes that happens, and sometimes it actually doesn't meet your fully expected specifications. Next one, financial bankrupt or acquisition of supplier. Bankruptcy, if you're looking at what is some great agile companies, and oftentimes startups have some great technology and some great promises. Of course, there's financial risk there you need to be consider. In acquisition, sometimes that's an acquisition of maybe a competitor buying a competitor, which of course can cause problems if they discontinue that competitor's product, or even the terms and conditions. Sometimes the contractual terms and conditions will change based upon that acquisition. So something to keep in mind. And one of the things to do is to really look at those suppliers. If you're, the partners you have on the call today, been in business a couple of decades or more, oftentimes they have pretty mature business models. And so you're probably not going to see a lot of changes in that in terms of financial structure or the changes of some of those contracts. And so that's one thing to keep in mind. Change of terms, scalability. Of course, change of terms can happen from a contract, and especially through acquisition. But scalability too, you really want to look at how scalable do you need this to be, and how much deployment practice really does that supplier have. If they have a bunch, again, a mature business model, probably don't have a lot of problems. But if it's a fairly new company and a startup or something like that, then you may have some hurdles, some things that you need to work through on that. And then, of course, the last one, vendor locking. In terms of vendor lock-in, of course, suppliers love that, but you, of course, need to make sure you have some flexibility in case something does happen with that vendor. So those are some of the considerations on the buy side. If you jump over to the make side, as you know, we're all technologists here, and technology, sometimes it's hard to overcome some of those projects, some of those expectations. And so some of those technical gaps that we hope we can overcome when we're doing this ourselves, sometimes are difficult and challenging, and there's the unknowns out there oftentimes that we hit, and we just have a difficult time overcoming. Technical dead end, same kind of issue. If you get into certain physics and some problems that you just cannot overcome, you can run into some of those. Versus, of course, on the buy side, typically it's some proven technology or close to proven on that. And then feature creep. This one's a tough one to control. But if you have good technical management, good business leadership, you can typically control this. But we're human. We love to think and dream and of all the great things we can do. And so you can oftentimes get feature creep and really try to work with your product management team to make sure that you have a specification in terms of what you're actually making, and really stick to that to not have that those features creep. And then a methodology. And this one is really, how many methods about your company do you have, certain processes and systems really in place to manage through that? And have you done this before? Is this typically part of your DNA and something you just do? And just to take you through just a little example here, this one's more of a cybersecurity example. As you know that, security is becoming more and more of an issue. IoT attacks. Right now, most of the hacks are at the PC level, but just a report at Microsoft where over the last year, 30% increase in attacks on mobile phones. And these are on Microsoft employee mobile phones to really try to break into Microsoft's network, because it has one of the largest enterprise footprints in the world in terms of the cloud. But you can see all these different types of things that I'm sure you know and are really working to overcome. But these are the types of risks that you can look at just in terms of building the devices. We've actually done this ourselves, and really through the Xbox, we came up with these 7 properties. In the story there on the Xbox, really the first one that we sent out took about a week to hack. And so we went back to the drawing board and really came out with a 2nd generation Xbox. And that one took a couple months. It also took a little bit of soldering to do that. But it actually happened. And so individual by the name of Galen Hunt worked in Microsoft Research and really came up with these 7 properties. And when they came out with Xbox One, applied this, and that one hasn't been hacked. So we really developed this in terms of this types of what we need for secure devices. And have a partner that actually went down the path and actually was doing and making a secure service for embedded devices themselves. They spent millions of dollars doing that and had a pretty good service. But they really came and said, Scott, we're not meeting all these 7 principles, and we really would like to use that and leverage technology that's been developed for that. What we did is came up with something called Azure Sphere, and this just gives you a sense of the types of things that you can do and really mitigate risk. And this requires security at the chip level. There's actually IP embedded in the silicon, basically an operating system that is containerized and there, as well as a secure service to really be able to update that chip. And something that we do for 10 years just to make sure that you can actually secure that and minimize that kind of risk. But these are the types of examples, the types of things that you want to go through when you're evaluating basically different elements of the device that you're building, the solution that you're building. So just to close out risk, I think you have a lot of, there's short-term risks, things that you can't control when you actually go in and look at buying that, versus if you're making that longer-term risk, it can be a really good direction. Typically, you want to make sure that you have a long way in terms of the project, and you have a certain amount of volume with that as well in terms of the direction you're going. The next section here is really total cost of ownership. And this one, again, is something that's oftentimes late in the process that we think about in terms of what about the ownership, because this typically gets into maintenance or support or things like that. Oftentimes when we're developing a product or a solution, we maybe don't think of upfront. But there's different types of costs associated with that. Of course, the upfront development, a lot of what we've been talking about, production in terms of just producing that, hosting, maintenance, support, those types of things are the different types of costs that go into either maintaining that solution, that service, whatever it is that you're developing. And in terms of that return on the investment, there's going to be short-term investments as well as long-term investments that you need to look at. And typically what you see in these, it's, how long a term is this solution or service and what level of volume are you going to reach? And of course, the longer term the solution or service is going to be on, or the higher the volume you're reaching, then you're going to be more and more toward make, versus the shorter term type buy. And you can see just some really good points in terms of the buy side here. If you look at it for development, of course, it's going to be lower cost up front because you're not going to be doing that development. You're looking at buying those solutions, that service up front. But running that, you can see in the long term, of course, that can be quite high because you're actually buying each of those solutions and services and not amortizing some of those costs internally. You can also have some follow-up integration of the cost in the system, but that can also, on the buy side, you need to make sure that you consider that impact as well. And of course, dependency on the supplier. And again, this, when you're looking at suppliers, if you can evaluate those suppliers, are they fairly mature businesses? Or do they have fairly mature business models? Probably won't be a lot of impact or changes. However, if they're more of an agile or kind of on the leading edge, you may see some impacts in terms of some of those price increases, whether it's a service, licensing, some of the costs associated with that. And then on the make side, if you're making something in the TCO equation, you can see it's going to require more investment up front. But if you could make that investment, you can really look at scaling that out and supporting that. Those economies of scales is really you build that out. And then, of course, the recurring costs. If you make that, you might have some, but you're not necessarily buying or servicing or supporting that. On the other hand, if you buy that. So TCO is something to consider. And I think a good example of this one is really if you look at cloud and in terms of the cloud computing, there's a few different approaches here. What we've done years ago is primarily that traditional on-prem, where we take and individuals, we take the whole stack, networking, server, visualization, OS, runtime in the application, where a company would actually own all of that. Of course, that's the make side of that. And you can see you take on a fair amount of maintenance. And then what we've done is really partition this out, and whether it's infrastructure as a service, platform as a service, or SaaS, basically, software as a service, that one where you're actually just paying a license and someone else is taking care of that whole thing, for you. But a kind of a great example in terms of the TCO that's associated with these different decisions that someone would make depending upon what type of service, solution, device you're actually building out. So just a good example, I think, from a TCO perspective. Lastly, just to kind of close this out, key takeaways, less expensive in the short term in terms of buying that, but as you look at longer term service and support, that could be fairly costly. Of course, if you're going to make that, it's going to be more upfront, but longer term, you can amortize a lot of those costs in terms of that service and solution, as well as gain a lot of those that expertise that you need internally to do that. So that kind of closes out the TCO conversation. So Dylan, we'll pass it back to you to kind of wrap us up here.
Perfect. Well, we've got a little bit of time for some questions here, so we're going to jump into that right now. I guess the first question I'm going to pitch to you, Harrison, but I'd be interested to hear if other people have something to say as well. When you're talking about time to market, there's this make versus buy discussion. Really, there's also a discussion between being first and being best. Can we rephrase it in that way? Does that make sense to talk about time to market in that sense?
Yeah, absolutely, Dylan. I put this in the context of our MCU framework a lot, actually, because for those that have used some of the open source solutions that have been out there for several years, there is an advantage, right, to showing up late to the party and learning from others' mistakes. So typically, in a time to market scenario, the clear advantage, right, is even if you're out there first and you have some things to improve upon, there's a brand awareness element that comes with that, right? You're out there, you've put something new and ideally strongly differentiating from everything else that's come before it. So even if your first couple iterations need some work and improvement in the context of IoT, that's almost expected these days, right? I think a lot of consumers go out and pick up a device and they bring it home and it does a couple good things, but that there's more to come down the road. And that's where some of these expectations around continually improved and built upon and expanding into the ecosystem are coming from.
Yeah, just want to add to that from the hardware perspective also, and in general as well. Like, I don't think there's such a thing as a perfect product. So at the end of the day, you are going to do iterations no matter what. And if you get something out there earlier, you start getting more feedback. Also, you start selling things. So hopefully you can start seeing some revenue coming. And that hopefully allows you to do those iterations. I've seen a lot of companies trying to make this perfect product and they just go bust just because they're not selling. No money is coming in. They're just trying to improve in their own silo, whatever they're trying to do, and that's also not such a good strategy. But obviously, you want to find that balance. It's always this balance. Like, you don't want to put something to the market that is completely rubbish, and people just gonna hate you for that. So you want to have a decent product, and then you want to have it out there, and hopefully you're first or one of the first, and you have some good things going on there, and then you can start selling them and getting more revenue to you, more money, more profitability to you, and then you can start iterating and building based on that.
Pierre, maybe I just pass this on to you then. Being first can be a really big advantage, but when it comes to ownership, is being bound to a provider really a worthwhile trade-off there when it comes to ownership?
I think it depends how much you're going to bound yourself with the provider, and again, I kind of go back to this, why I see from the hardware perspective, why I see two completely different approaches coming together and working with the system on modules instead of full-blown compute, off-the-shelf compute, or full-blown 100% control and chip-down design. Is that you want to find that perfect balance, or good enough balance where you are in control of the most valuable part of your design and the most added value part of your design. That's what you want to be in control. And whatever are the other things are just a vehicle to deliver that added value. And you should be choosing the right partner for the delivery vehicle, but you probably don't want to be in control of that per se.
Pierre, I saw you nodding there, but we had a comment. we had a comment come in from Bertrand as well. It said, look, even when you're making, if you're relying on external skills, there's going to be risk for your ownership all the same, right?
Yeah. In fact, it depends. For sure, at Witekio, we are used to work for our customers. So that means there is no question here. As soon as we are doing something, the ownership is for our customers. But for sure, this is a legal stuff, and all companies that would like to subcontract something have to be careful with the contract they are signing. But for sure, this is our way of working at Witekio. That's why I summarize that like that. And just to confirm what have been shared till now, I fully agree that the key topic here for yes or no around the buy approach is really the added value and the pure proposition, the value proposition of your solution. So let's focus first on your value proposition, and then analyze all around what are the risks, and on your pure value proposition that could be for some of our customers just a basic algorithm, or it's important to make it. For the rest, it have to be deal with the legal stuff, with the technical, with the time to market, with the existing solution, with your competitors, and everything have to be put in a big bag and check to validate what is the most important for you.
Scott, I might pivot to you there, because the guys are starting to talk about legal risk and financial risk. You mentioned cybersecurity as well, but there's a lot of people who are going to be involved in doing the risk assessment process here, right? It's not just a product manager.
Definitely. I mean, it's you really. I think it's a great question, and also think sometimes we forget to do that. But I think a really good point, Dylan. Sometimes we maybe assess that ourselves, but yes, we need to go to basically the different vertical organizations within the company, and talk to the different vertical organizations in terms of what product, what solution are we bringing to market, and who all is this going to impact? Because it can be finance, it can be legal, but it can be HR, it can be all sorts of things in terms of the impact that these can have. We at Microsoft actually have a big evaluation process around like PII and things like that, data. I know Pierre talked about data in terms of who owns that. That's a big risk there too in terms of that, and we really want the end customers to own that. In terms of Microsoft's approach, I mean that really helps us to kind of de-risk a lot of the solutions and services that we provide. So yes, you need to look kind of across your organization, in addition to what the solution is, to make sure that you account for all those different risks.
And Harrison, I've got another question I'm going to point your way. It might be the last one we get to, actually, but you talked a little bit about, in the culture section, the importance of people and either the team that you have on hand or the team that you're hoping to build. A lot of time in these discussions, we talk about the tech and we talk about the stack and the different parts that we're going to make or buy, but people are still a big part of this, right?
Yeah, absolutely, Dylan. I've given a couple other talks on this concept in the past too, and I think coming from a development position myself too, there's an element of the make, right, that is so tremendously important, not only to the larger picture of the organization, but the individual contributor as well, right? Having the opportunity to be involved in as many different projects as possible and building up your own personal skill sets is tremendously valuable. So there's certainly a side to the make, right? And again, it's not black and white. There's elements that you'll pull off the shelf, and if there's enough exposure to what's going on under the hood, you can still learn from that. So there's still an element of make there, the integration of that off the shelf component. But yeah, I mean, everybody should have the opportunity to get exposed to as many different things in their career as they want to, and to really have that path to grow and develop. So yeah, I think, again, that one is super not black and white. I put a poll out there actually that some of the attendees answered, does your company fit in the make or the buy? And I think you'll get different answers depending on which part of the organization you're in, right? Maybe the hardware team buys everything, but the firmware team is doing everything they can from the ground up. And so, yeah, there's going to be different answers there, but it largely depends. It's very not black and white, and you will see an impact to the overall culture of the organization. But I think there's some components that come with make that's really important there.
That's great. Thanks. We're really coming up on time here. If we can summarize a little bit of the advice there, I guess if we're going to choose make, that's really looking at the core value. We can choose buy when something's not core. If we're not trying to reinvent the wheel. Every situation a little bit different, but that's really a guiding principle there. If you are going to go out and buy, of course, you want to audit your providers. You want to really anticipate, as Pierre was talking about, that reversibility. Don't neglect those integration efforts and think about the long term. Sure, you're going to get to market a lot quicker, and that's going to have some big advantages up front for business, but you need to think a little bit longer term as well. On the other side, if you're going to be making, you need to think about the methodology and the technical skills, that HR and that culture that you have on site. You can use certain accelerators. You can think about platform, which will slow things down the first time, but speed things up for the products that come in the future. Open source options can really help you as well. And you can bring in external knowledge too. And that's really going to help you move a little bit faster as well. In the end, if you want to go a little bit further, there are some discussions that you can go through. You can book some discussions straight away with Witekio, but of course you can contact any of our guests and any of our experts that we've had on here tonight as well. In the next couple of days, you'll get an email with options to contact them and also the replay of this webinar, so you can play that back for yourself or share it around your organization for people who couldn't be here tonight. We are right up on time. Thanks to Harrison, to Scott, to Pierre, and to Anatoly for participating here tonight. Thank you for attending, and do look for that email in the next couple of days. Have a good day, have a good afternoon, and have a good evening. Thanks for your attendance.
Thank you, everybody.
Thanks all.
Thank you.